Good morning, good afternoon, and good evening. You are listening to the Revolution Health Radio Show. I'm your host, Steve Wright, co-author at scdlifestyle.com. This episode of the RHR show is brought to you by 144.me. This website and this program is a 14-day healthy lifestyle reset program that Kresser has put together to help you if you're still struggling with, for instance, weight loss, maybe even weight gain, sleep issues, autoimmune conditions, digestive health. Basically, if you're having any health-related conditions and you're still not where you want to be, optimizing your diet, your sleep, your movement, and your stress is really the foundational principles to getting these problems resolved. And what Chris has done is put together a 14-day step-by-step program that's going to walk you through fitting all these new changes into your life. And as we all know, implementing healthy habits can be a real struggle. So it's really good and really wise to work with somebody who's done this with hundreds and thousands of other people, and using science-based principles and habit-based principles, it will make it easy for you to implement these things into your life and take your health up to the next level. So check out 144.me. Now with me is integrative medical practitioner, health skeptic, and New York Times best-selling author Chris Kresser.
Hey everybody, it's Chris Kresser here. We're going to do something a little bit different this week. I have Dr. Amy Nett with me. She is a staff physician at the California Center for Functional Medicine, our clinic, CCFM. And I decided to ask Amy to come on the show and discuss methylation. I know we did a show about this a while back, but since then we've received a lot of questions from people asking us to just simplify things a little bit. And Amy and I have been seeing it a lot in the clinic. We're treating it a lot now. We're kind of in a deep dive in terms of researching it and working out what it means for us and our patients. So I thought it'd be a good idea to bring Amy on and talk a little bit more about it in simpler terms and in more practical terms, like how we test for methylation problems, what happens in the body when methylation isn't working right, and of course, how we treat it. So welcome, Amy. Good to have you on the show.
Thanks so much, Chris, for having me on the podcast this week. I'm excited to be here and talk about methylation a little bit more because, as you mentioned, it is something we're seeing more and more in the clinic and really working on optimizing methylation in a lot of our patients and seeing some really good results. But as you mentioned, it's also something that can feel like a pretty overwhelming topic. So I'm hopeful that today we can clarify it a little bit more and make it seem a little more approachable.
Great. Yeah. And we'll, I'm sure what will happen is after this, we'll get some more questions and then we can do a follow on. It's a huge topic and of course we could do several episodes on it and maybe we will. But before we do that, before we jump in, for those of you, those of our listeners that aren't familiar with you, haven't read any of your guest posts on the blog and just aren't familiar with your work, why don't you tell us a little bit about your history, your background, and how you came to be a staff physician at CCFM.
Yeah, of course. I initially did my undergraduate training at UC Santa Barbara, where I earned a bachelor's degree in pharmacology. And I really loved science and also working with people. So I decided to go to medical school, and I earned my medical degree from Georgetown University. And for a number of reasons, I fell into radiology, and radiology, for people who aren't familiar with that, it's really biomedical imaging. So it's interpretation of MRI, CT, ultrasound imaging. And I did my training in radiology at Stanford University, which is what brought me out to the Bay Area. And after completing the basic residency in radiology, I ended up doing specialty training in pediatric radiology, also at Stanford University. And in doing the training in pediatric radiology, I saw a lot of kids coming in with autoimmune diseases and a lot of diseases that really seemed like sort of adult onset diseases, chronic diseases, seeing a lot of things resulting from diabetes or obesity. And I've always been interested in nutrition and lifestyle. And so seeing these kids coming in with chronic diseases really made me feel like there had to be a better approach to medicine and to healthcare. And then along the course of having some of my own medical issues, I actually came across functional medicine, came across your blog, Chris, and the podcast. And that's where I really started diving into functional medicine and learning everything I could about it. And it just seemed like such a better fit for me as well, both as a patient and a practitioner. So fortunately, you had a job posting for wanting to bring in another clinician to help you with your practice. And as far as I'm concerned, things worked out, and here I am. So I started training with you, I think it was about a year ago now, I think March or April of last year, and started seeing my own patients. I think it was October, November that I started seeing patients, and now increasing that practice.
Yeah, we're really lucky to have Amy. She was the one we chose after, I think we received over 100 applications and reviewed, probably 10 or 15 very carefully and did a whole round of interviews. And Amy was the one we chose. And we're really lucky to have her because she's extremely diligent in her research. She's research oriented. And of course, that's very important to me and to Dr. Schweig because it's a big part of our work. And she's a very fast learner and has just really kind of jumped in and gone deep into the study of functional medicine. And we worked very closely together. She observed virtually all of my appointments for a long time before she started seeing her own patients. And, we talk pretty much every day and review cases. And it's just been great to have her support and be able to treat more patients and to offer more support to my existing patient base. And we're really glad to have Amy. So let's jump in and talk, if we can kind of think about this as methylation 101 or methylation for dummies. Let's talk a little bit, Amy. Why don't you give people a kind of basic primer on what methylation is, and then we'll go into talking a little bit about the processes in the body that are affected by methylation.
Okay, sounds good. So it's important to realize that in some respects, methylation is actually very simple in that it's really just a biochemical process. But it's also a very intricate process that is absolutely central to our physical, emotional, and mental well-being. It's essential for the optimal function of almost all your body systems. It occurs probably billions of times every second. In doing so, it helps repair your DNA on a daily basis. It helps keep inflammation in check. It replenishes the compounds needed for detoxification, and it helps maintain a stable mood.
Yeah, so it's interesting. One of the reasons I think methylation is hard to describe is that there's not much it's not involved in, and when you're talking about a process that is so ubiquitous and so important, it's almost like saying, well, why is breathing important, or why is blood flow through your arteries and veins important? But as you pointed out, it helps to really just think about all of the physiological things that you mentioned: repair of DNA, keeping inflammation in check, detoxification, and mood. Those are the ones that I think if you want to highlight a few areas that methylation is crucial for, those are probably the ones that stand out.
Of course, yeah. So if we turn to thinking about the different processes in the body that are affected by methylation, we mentioned in particular mood. So if we look at how methylation supports the brain and nervous system, we can think about at least two different functions where this works. One is in neurotransmitter synthesis and degradation. And this is really important in stabilizing mood and improving stress resilience. So some of our patients, one of the tests we do is looking for genetic predispositions as they relate to methylation, and one of those is COMT or COMT. And patients who have this mutation may have a more difficult time recovering from a stressful event. So we know that if someone experiences something stressful, whether that's a deadline at work or conflict with another person, it could actually take them longer to return to baseline because they don't metabolize those sort of stress neurotransmitters like epinephrine and norepinephrine as rapidly as someone might without this mutation or without impaired methylation.
Mm-hmm. So let's talk a little bit about DNA too, because this is, of course, arguably one of the most important functions of methylation is affecting gene expression.
Mm-hmm. So methylation does absolutely affect gene expression in a few different ways. And one of the topics that's increasingly being discussed is the area of epigenetics, which is differences in individuals that can't be explained by genetic differences alone. And methylation is one of these major factors in epigenetics, which means that it helps to explain why, for example, identical twins who have an identical genetic code may have a slightly different appearance or could actually suffer from different diseases. So,
right, and that's even true in diseases that are highly heritable, like schizophrenia. Identical twins, there's a 50% concordance rate, which means there's a fairly high likelihood that if one twin has it, the other one will have it, but it's not 100%. And epigenetics, and of course the environmental factors that affect epigenetic expression are probably what make up that difference.
Right, exactly. And when we think about how methylation does this, sometimes I think it can be difficult for patients sometimes to sort of visualize what methylation actually is. So I think it could be worth saying that methylation is a term that comes from biochemistry, and you can think of methylation as the body essentially adding a tag or sort of like a work order to parts of DNA, maybe a gene or to a vitamin or an enzyme. And by adding that tag, or what's technically called a methyl group, which is why it's methylation, when this tag gets added to that gene, vitamin, or enzyme, it actually changes the function. And in the case of DNA, by adding this methyl group or this tag, however you want to think about it, you're actually turning genes on or off. So this can be referred to as gene expression. So the ways in which methylation affects our DNA is incredibly important. And again, one of these reasons is because many of us have genes that predispose us to certain diseases like cancer, as you mentioned, maybe schizophrenia. But by turning these genes off, they're not expressed. So we may be able to actually reduce our risk of developing certain diseases, some types of cancers, by optimizing our methylation.
And that's really, really crucial to understand because, back maybe in the 70s and 80s, even into the early 90s, there was a lot of excitement about sequencing the human genome, and there was a lot of fanfare around that, and bold promises like, once we do this, we're going to have the key to human disease, and it's going to lead to all kinds of medical breakthroughs and revolutionizing the treatment of chronic illness. And that just didn't really happen. And what our understanding now is that genes alone account for less than 10% of disease. And the exposome, which are all the environmental factors that an individual is exposed to from the moment of conception to when they die, the contribution of the exposome plus its interaction with genes and gene expression is really what accounts for 90% of the diseases that we're dealing with. So here we have methylation as a process which really has a profound influence on the epigenetic expression of genes, which really boils down to determining our risk of chronic illness. I mean, that's really what we're talking about here.
Absolutely. And this is something that we can modify. And that's why a lot of times we want to do everything we can to really optimize our methylation. Because as you mentioned, with genetics, there are some things that we can't change. But certainly those may often be really the minority of what contributes to certain diseases. And methylation is absolutely something that we can support through a number of different means.
All right, so let's talk a little more specifically about what happens when methylation, what the physiological processes are in the body that are affected by methylation, and then what can go wrong. So as we've already discussed, almost all the body systems are affected by methylation, or the addition of the methyl group, to be specific. So therefore, as one might expect, the signs and symptoms of impaired methylation are pretty vast. But they can be broken down into a few key categories. So let's go over those one by one.
And yes, as you mentioned, since almost all of the body's systems are affected by methylation, or as we said, this addition of a carbon group, the signs and symptoms of impaired methylation are pretty numerous. Something I want to say we probably see more commonly with patients coming to the clinic is that Methylation can be associated with production of important compounds needed in cellular energy production and metabolism. So oftentimes we might see patients presenting with fatigue or decreased exercise tolerance. Sometimes this means that people might have a more difficult time losing weight.
Yeah, cellular energy production is crucial, not only just for our experience of energy, but also, of course, the function of cells, because all cells require energy to function, and the body is just made up of cells. But one of the other key symptoms of impaired cellular energy production or mitochondrial dysfunction, is another way of talking about that, is pain. So people who have chronic pain, like fibromyalgia type of symptoms, or people who have chronic muscle aches, or if they, you mentioned exercise intolerance, Amy, which means they might often, if they just do a small amount of exercise, they feel really wrecked after that and have a difficult time recovering. That's something that we would expect to see with this disrupted cellular energy production related to methylation.
Yeah, and when you talk about methylation and exercise, there was actually an interesting study that looked at how exercise does affect methylation. And this study found that exercise actually increased the expression of genes associated with energy metabolism, insulin response, and inflammation within the muscles. So it was interesting here that exercise benefits muscles not just from the physiologic benefits of using them, but also by actually changing the genes that are expressed within that muscle.
I love that study because it's just a perfect explanation or example of what we've been talking about. We've been focused on the sort of biochemical and physiological effects of something like exercise, but now we're learning that it doesn't just have a mechanical effect. It's actually altering gene expression, which of course, again, then reduces our risk, is part of why exercise reduces the risk of so many different diseases.
Yeah, it's pretty amazing, the cascade of benefits that you can get from exercise.
Yeah. Let's talk a little bit about brain and nervous system function, because that's another big area where methylation plays a role.
Yeah, and we talked a little bit about the role of methylation in terms of promoting synthesis and degradation of neurotransmitters and stress resilience. But methylation is also really important in supporting myelin. And myelin can be thought of as the sort of protective coating or insulation along the nerves. So if you have injury to your myelin, you can almost think of this like having frayed electrical cords that have vulnerable and exposed wires. So methylation is important in helping to maintain the integrity of the myelin, and maintaining a healthy nervous system is really one of the best things we can do to support mood and cognitive function. It's actually injuries to the myelin that underlie changes seen in multiple sclerosis. So an incredibly important structure in the nervous system.
Yeah, this is crucial. And we see so many patients with neurological issues ranging from just kind of mild neuropathy, numbness or pins and needles tingling in the peripheries like the hands and feet, to more serious conditions like multiple sclerosis. And of course, those are multifactorial conditions, so we're not saying that methylation is the only factor, with these conditions, but it often is at least one factor, and people do tend to improve if they have impaired methylation, and we give them some support.
Yeah, and that's really important to emphasize that methylation is a very important piece in the puzzle, and I think it's rarely the single answer, particularly in these complex issues. Of course, like multiple sclerosis, very multifactorial, but methylation is one of those foundational pieces that is just best to optimize.
Right, and we'll probably get into this a little more later, but another thing we're thinking about is impaired methylation can cause a lot of problems, but there are also a lot of problems that can mess with methylation. So it's, as usual, it's a little bit of a chicken and egg situation where, for example, if you have SIBO or other gut issues or nutrient deficiencies, those are going to impair methylation. So sometimes focusing on methylation, is the right step. Other times, fixing all of these underlying problems that can cause poor methylation in the first place is the right step, and other times doing both at the same time, and which is probably more often what it it tends to look like in our practice is the right way to do it. So there are a couple more things I think we should talk about as far as methylation goes, and that's detox detox capacity and immune function.
Yeah, and I think detoxification is one of the most important roles that methylation plays in our body. And specifically, methylation helps to remove toxins from the body. So having impaired methylation can actually block or inhibit detoxification. As a result, you may have a higher heavy metal burden, which could lead to something like mercury toxicity, or at least contribute to something like mercury toxicity. Or you may have a more difficult time recovering from something like SIBO or chronic yeast overgrowth. And while we're sort of promoting optimizing methylation, it's important to realize that you can also over-methylate. So it can sound like this incredible answer, and it often is, but we often caution people when we do appropriate testing, we find that someone might benefit from methylation support. We do caution all of our patients to start methylation support slowly. And one of the reasons is because improving methylation will actually lift the block on detoxification. And as a result, toxins can move into the bloodstream, activating cell-mediated immune response, and that can overwhelm your detoxification, making you feel as though you have sort of a flu with fatigue, malaise. So starting methylation support should be done slowly and looking for these symptoms of increased sort of detox symptoms.
Yeah, that's a great point. And we see that regularly in our practice where people do have, when as they become more able to detoxify, and methylation also would increase their, as we're about to discuss, their ability to fight intracellular infections, for example, chronic viral infections or other infections. So if you all of a sudden you make all of that function better, you could definitely feel worse. And so it's important if you're doing any kind of methylation protocol, especially if you're doing it on your own, to move slowly and not overwhelm your detox system, because that's not going to be helpful in the short term or the long term. So the other thing is immune function, and I think both detox capacity and immune function are maybe two of the more important aspects of methylation, especially today when we're seeing such a proliferation of autoimmune conditions, and when we find ourselves living in a world where there's more exposure to environmental toxins than we've ever had before in human history by orders of magnitude. So, with immune function, it's really, I've talked a lot in the past about the importance of maintaining healthy T regulatory cell function, cell-mediated immunity, ability to fight off infections, if catching colds and flus. If you find yourself catching every cold and flu that comes through town, then it may be that methylation is impaired or not functioning optimally for you. And there is some research linking poor methylation to autoimmunity. So it's just another consideration. It's another one of the areas that we kind of, if someone's having a lot of problems with immune function, that will be as an invitation for us to consider methylation as one thing that's possibly going wrong. So I know that's a lot that we just shared. I hope that wasn't too far off the 101 for dummies theme there. Why don't we just talk about some of the symptoms that are associated? We've mentioned a bunch already, but it might be helpful just to do a list so that people can find themselves in this.
Well, and there's a pretty broad range of symptoms and conditions that can be associated with poor methylation. And I think, as you just said, we've already mentioned quite a few, but I'll mention some of the more common signs and symptoms we see with our patients presenting who end up having methylation issues. Fatigue, as we mentioned, that can be a really common sign of poor methylation, just not having the energy, not having cellular energy production. We also see obesity can sometimes be related to impaired methylation. Infertility and recurrent miscarriage. We also see, as we mentioned, there's a lot of nervous system manifestations. So that might be something like anxiety, depression, sometimes insomnia or other sleep disturbances, and even some of the more severe neuropsychiatric disorders, such as bipolar disorder, have been linked to certain methylation issues, whether genetic predisposition and also impaired methylation resulting from that.
So that's a good list, and as Amy said, it's not complete. So if you're suffering from a lot of those symptoms, it could be that methylation is playing a role. If you didn't hear some of your main symptoms, it doesn't necessarily mean that methylation is not playing a role. Of course, a lot of the symptoms that we mentioned are pretty non-specific, which means they could be caused by any number of things. Like almost that entire symptom list could be caused by gut issues alone. So you can never really make a diagnosis based on symptoms alone, which is why we tend not to pay as much attention to symptoms in functional medicine as in other approaches. But that should give you a general idea. So let's move on and talk a little bit more about why methylation goes south in the first place. And I think this can really be broken down into two categories, which is genetic predisposition and diet and lifestyle factors, and also disease states or health problems that can influence methylation. So why don't you start us off with discussion of genetics?
Okay. I want to take at least 1 or 2 minutes to mention MTHFR, because when I speak with our new patients who are coming to the clinic, a lot of patients come in and they've heard methylation, they've heard this buzzword, they know it's important, and so often they're excited to tell me what their MTHFR is. So they come in and they say, well, I know I'm already heterozygous for A1298C or C677T, and MTHFR seems to be what's most popular out there right now. But it's important to know that there are at least a dozen other genes that are associated with methylation. And for those of you who haven't heard of MTHFR, MTHFR stands for methylene tetrahydrofolate reductase.
Thank God for the acronym.
Yeah, that is a mouthful. So we've said it once, so from here on out, we're going to stick with MTHFR. So MTHFR is one gene that's involved in the methylation cycle, and it probably is the main driver of methylation. And specifically, it makes methylfolate. But again, when we're really looking at methylation, we need to consider all of the genes, so over a dozen genes that contribute to the methylation cycle.
Yeah, and since this is a 101 podcast, I don't think we're going to go into a lot of detail on those other genes. It starts to get pretty complex. I think the takeaway here is that there are genetic mutations that do affect your likelihood of developing methylation problems, and the MTHFR gene is one of those, and perhaps the most important, but there are many others that play a significant role as well. So other than genes, what else can we talk about that disrupts methylation?
Well, Chris, I think that's really important, because I've heard you say before, and this is so true, so worth repeating again, that genes load the gun, but environment pulls the trigger. So genes give us information in terms of helping us know where to look for potential problems in the methylation cycle, and maybe helping us to tailor treatment. But really, it's the lifestyle, diet, disease states that are probably more important in knowing how someone is actually methylating. So we need to consider a patient's internal and external environment in addition to the genetic predisposition to really understand their functional methylation, or how they're actually methylating. So
let's drive that home a little bit more, because as you know, this is like a pet peeve of mine, and there are websites out there where you can, connect your 23andMe results, and they will spit back your methylation genetic profile along with a list of supplements that you should take solely on the basis of the genetic mutations that you have. And where you can start to see the limitations of this approach very quickly is that oftentimes with those computerized algorithms, one mutation suggests that you would tolerate methyl donors like methylfolate really well, and so they'll list those out, next to that mutation. But then another mutation you have further on down suggests that actually you wouldn't tolerate those methyl donors, so it tells you to avoid methyl donors. And this is just one example and one reason why we cannot rely on the genetic profile alone to tell us what's actually happening in the methylation pathways. And Amy and I have seen numerous cases where somebody has no really significant mutations in MTHFR or other significant methylation-related genes. But when we go and do some functional methylation testing, which we'll come back to in a little bit, they're kind of a disaster as far, they're having huge problems with methylation. And then on the other hand, we've seen patients who have mutations where you would expect them to be pretty challenged in terms of their methylation, but when we do a functional profile, they're actually methylating really well. I'm homozygous for MTHFR C677T. Again, that's a mouthful, but it means I have a mutation in MTHFR, which would predict that my methylation doesn't work well, and that I would really benefit from methylation support. But I've done a lot of testing, functional testing on my methylation, and in almost all cases, the results have been very clear. And I've experimented a lot with methylation, all kinds of different methylation support, and I just don't really feel that different when I do it. So it's really important to consider this and to not get too caught up in what the genetic mutations are without doing that functional testing.
Yeah, and as you said, this probably a good reason to work with a practitioner if you do suspect impaired methylation and want to focus on that, because right now the research in methylation is so new, and there's a lot of new information coming out, and trying to read on the internet what you should be doing about methylation, I think can present a lot of conflicting information right now. So probably best to work with someone who has some experience.
Yeah, and some early pioneers in the methylation world, were working a lot with kids with autism and some pretty specialized populations, and they developed some really interesting theories about the significance of various mutations. And there's unfortunately very, very little peer-reviewed research, if any, to support some of those ideas. And that alone is not a reason, lack of proof, as they say, is not proof against, but there have been some challenges to some of what's been presented. For example, the idea that CBS upregulation in a gene called CBS leads to, high levels of sulfate and glutamate and alpha-ketoglutarate and taurine and other substances in the urine, which then and the treatment for that is to, according to this theory or approach, is to reduce your consumption of animal protein. So, when I heard about all that, I was pretty reluctant to just jump in, because I know if you eliminate animal protein, you're going to be adding something else, right? And it's probably going to be a lot of grains and carbohydrates and things that a lot of people don't feel good on. So when I dove in and did a lot more research, I found that there really wasn't any peer-reviewed research to support that interpretation, and there were actually some problems with just basic problems with the way that was being explained. So it's just another reminder to be careful with how you interpret all of this information and not ascribe too much importance to the genes. I think we beat that horse to death, so we can probably move on and talk about what else affects methylation, since we've I think made it abundantly clear it's not only genes.
Okay, so now that everyone's in agreement that we're not going to treat methylation based solely on genetic predisposition, probably the more important factors affecting methylation are largely under our control, diet and lifestyle related. So of course, poor diet is something that's going to impair methylation or tax the methylation system. And this is in part because if you're eating a standard American diet, or a diet that includes a lot of processed and refined foods, that's going to be contributing to inflammation. You're probably going to have inadequate nutrients, maybe insufficient B vitamins, zinc deficiency, or even magnesium deficiency. And all of these vitamins and minerals are important cofactors in supporting the methylation cycle.
Yeah, that's crucial. And we know from studies that a shocking percentage of Americans are deficient in all kinds of different nutrients. So this is a real problem, and I think one of the biggest. And even people who are doing really healthy diets can often be deficient, as we've seen, Amy. And that's because of things like SIBO, low stomach acid, leaky gut, which impairs nutrient absorption and increases inflammation in the gut barrier. So even those of us who are following a really great diet, if we've got one of these gut issues going on, we'll see deficiencies of nutrients. And we do, organic acids testing and other kinds of nutrient status testing where we do see this even with people who are following a good diet.
Absolutely. And any sort of chronic gut issue, as you mentioned, leaky gut, chronic infection will impair nutrient absorption and also impair methylation. Similarly, having a chronic infection is also going to contribute to an overburdened detoxification system. So having an overburdened detoxification system is something else that might impair methylation. That could be coming from environmental toxicity, heavy metals, maybe mercury toxicity, or high copper levels.
Mm-hmm. Yeah, pesticides, fungicides, volatile organic compounds, phthalates. There's so many things now that we're exposed to that we really weren't for the vast majority of our evolutionary history, and because of that, we didn't really evolve efficient defense mechanisms to deal with those kinds of toxins. Whereas with some of the food toxins, we've been exposed to them forever, and so we have fairly effective ways of dealing with them, and that's not really the case with environmental toxins. I know we're getting a little short on time here, so there are a few other things I'm going to quickly go through. Stress and lack of sleep, big surprise. Pretty much any discussion of any health problem, we know that stress and lack of sleep are going to make those worse. We've got a variety of medications like antacids because of their effect on stomach acid and nutrient absorption, methotrexate, metformin, contraceptives, blood pressure meds. All of these can affect levels of B vitamins, which are play a crucial role in methylation. And the last thing we should probably talk about, and this is a relatively new cause of methylation issues, which is taking too much methylation support, too many methylation supplements. And this can cause over-methylation, where you end up with feedback inhibition and reducing the body's internal production of methylfolate. So it's kind of like if you take testosterone cream and you're a guy and you eventually, reduce your ability, your body's own ability to produce testosterone. It's a similar kind of mechanism. So we're going to move on to talk a little bit about how we test and treat methylation. Yeah, why don't we start with testing, Amy, what we're doing right now in the clinic.
Okay. So as we mentioned, again, MTHFR seems to be the most commonly tested gene. When patients come to us and they've worked with other practitioners, they often know what their MTHFR is. But we prefer to do testing right now through 23andMe because they provide the most comprehensive genetic profile as it relates to methylation. And I think one thing that's important to notice is sometimes patients are reluctant to be tested through 23andMe because they have a concern that they're going to get, an abundance of genetic information, some of which might tell them that they're predisposed to something like Alzheimer's or Parkinson's. But the way we do this testing, we have patients order a test kit through 23andMe. It's a saliva test, so you collect a small sample of saliva, send it back to the lab. And then once those results become available, we have our patients run them through geneticgenie.org. You do the methylation analysis, and that way you're only getting the genes as they relate to methylation, because it's completely reasonable. We don't necessarily want to know our genetic predisposition to things that we have no control over, but here we're just looking at genes as they relate to methylation.
And I question even what those numbers are. Because those are just averages. So if it says you have this gene, you have 120% higher risk of Alzheimer's. Well, they're just looking at the general population and following a standard American diet and lifestyle that has those genes. And yes, those people may have that higher percentage risk based on those genes, but that doesn't mean you do if you're following a paleo type of diet and lifestyle. So it is just it's a very tricky, area, and for a lot of people, we just generally don't even recommend getting that kind of information. And 23andMe doesn't even offer it anymore, so you can't get it even if you wanted it. There are other services that you can plug your 23andMe raw data into to get more comprehensive methylation gene reports, and some of those I think can be valuable. But there's also a lot of data that we just don't know what to do with yet. And the reason I like Genetic Genie is it focuses on the mutations that we know the most about and that are the most actionable. And, particularly if people are trying to figure this stuff out on their own, which is already really difficult, using those more complex reports can be challenging because not only do you have to consider each mutation individually, you have to consider how the various mutations interact with each other and sometimes cancel each other out or sometimes amplify each other. So that's a whole other level of understanding it. And it's an example of why this can be so difficult. So in addition to the genetic testing, we also, I mentioned before that we do functional methylation testing. So let's talk a little bit about that.
Yeah, and functional methylation testing, it really provides complementary information to what we're getting from the genetic information about methylation. So I think there are at least 2 labs that I know of that are offering functional methylation panels. I think it's Doctors Data, and then we more commonly use the HDRI, or Health Diagnostics Research Institute Functional Methylation Pathways panel. And that way we're looking at a number of different folate metabolites, because folate is really crucial in the methylation cycle at several points. And we also get a look at several markers for somewhat to tell us about detoxification. We look at oxidized and reduced glutathione and several markers for oxidative stress as well. So really get a sense of how that person is methylating, the degree of oxidative damage they have, and if they need detoxification support as well.
Right. So think of it this way. The 23andMe data, genes tell you what your predisposition is, what the likelihood is that you'll have problems methylating, but it doesn't tell you anything about what's actually happening in this moment, right now for you. And that's where the Doctors Data Methylation Panel or the HDRI methylation panel comes in, because that gives us the actual status of your methylation by looking at a whole bunch of different compounds that are involved in the methylation cycle. But above and beyond that, there are a whole bunch of other tests that we can do that either indirectly or directly can tell us about methylation. So for example, one is a urine organic acids test. And on that test, there are markers for active B12 methylcobalamin or adenosylcobalamin and active folate, methylfolate deficiency. So if we see those markers triggered, that might tell us that someone's not methylating well, and it might spur us on to do the HDRI test. Organic acids also has markers for cellular energy production and neurotransmitter metabolism and degradation, and also detoxification, which, as you'll recall from the beginning of this show, those are all major areas that are affected by methylation. So if we do an organic acids test and we see problems in one or more of those areas, then that can tell us that we should do some additional testing for methylation. So what else, Amy?
Some of the additional tests we might also consider might be a urine amino acids test. So when we were talking about neurotransmitters, well, amino acids are the building blocks for neurotransmitters. So oftentimes understanding the amino acid imbalances allows us for more targeted treatment.
Yep. There's some testing now like biopterin and neopterin, which can help assess the probability of a chronic infection or inflammatory cytokine stimulation, which can affect the whole methylation cycle. There are tests for nutrient deficiency. That also comes up on the organic acids tests, various B vitamins that play a role, that are cofactors in the methylation process. Of course, gut testing, which we mentioned earlier, that leaky gut, SIBO, malabsorption, low stomach acid can be a risk factor for methylation. Testing for chronic infections and heavy metal toxicity that could impair or slow down methylation. So a lot of the tests that we normally run in functional medicine can be relevant here. And then there are some specific ones that we might follow up with after we do some methylation testing, depending on the specific genes that that are mutated or specific things that we find on the HDRI panel. Okay, so finally, let's talk a little bit about how we address and support methylation.
Sure, and I think, again, just to mention this because it's so important, For most people, each of the steps in methylation can be affected by diet and stress management. So eating a nutrient-dense, low-inflammation paleo diet can really support healthy methylation, as well as doing stress management, whether it's daily progressive relaxation, sitting meditation, yoga, tai chi, but doing something to really help manage stress. For most people, that's going to optimize methylation. Most often, the people who come to our clinic do have something else going on and do require additional support to get methylation back on track. It's not an indication that they're going to be on methylation support forever or as a long-term requirement, but oftentimes we just need to sort of kickstart the methylation cycle again.
Right. That's a really important point because we often get questions from patients. Well, does this mean I have to be on, if my methylation's messed up and I have to do this protocol, do I have to take it for the rest of my life? And almost invariably, the answer is no. It may be that if someone has pretty significant mutations, they'll need some level of methylation support on an ongoing basis, but it's rarely going to be, the full protocol that we use initially.
Right. So the most important thing we do when addressing methylation, as you've already mentioned, is we make sure there are no other underlying contributing factors. So we always make sure we've tested gut, tested for metals. But then when we do realize we need to support methylation, we've done the appropriate testing, we provide a specific combination of B vitamins because those are the crucial sort of cofactors or nutrients needed in the methylation cycle. We generally also provide some liver or detox support and often provide cell membrane support, something like phosphatidylcholine to help support cell membrane integrity.
Right, and those of you that have been following my work for a while, you'll probably recall, or hopefully you've read the article on the differences between folate and folic acid. This can be confusing, and if you want to brush up on it, you can just Google Kresser, folate, and folic acid. But as a reminder, if you're kind of thinking, I've got a supplement and it's got some folic acid in it, so this is helping me with methylation. Remember that folic acid is a synthetic form of folate and has to undergo a number of conversions before it can be effectively used in the body and in the methylation cycle. And a lot of people don't do that conversion well, especially people with certain mutations related to methylation. So we'll generally use the more active forms, combination of folinic acid, which is kind of an intermediately active form, and methyl tetrahydrofolate, which is the more active form, 5-MTHF. And these enter the methylation cycle at different places and can have quite a different effect, especially if people have mutations that suggest that they might not tolerate the fully methylated forms of either B12 or folate as well. The intermediate forms like folinic acid in terms of folate, or like hydroxycobalamin in terms of B12, can be really important.
Yeah, exactly. And then once we've had someone on support for maybe a couple of months and we've treated any additional underlying conditions, whether it's SIBO or other, gut dysbiosis, we will repeat the functional methylation testing. So if someone's been on our methylation support, we'll see if they have sort of recovered, and if the parameters on that test look better, then we'll start actually weaning patients off of the methylation support. Because as you said, it's extremely rare that someone's going to need methylation support long term.
Yeah, as we've talked about on the show numerous times, it's a lot easier to maintain a system that's already in balance than it is to get it back into balance in the first place. So the heavy lifting is getting it back into balance, and then once it's in balance, you typically need less of everything to keep it there. And that's not only how it works with methylation support, but also gut treatment and many of the other treatments that we do. So before we finish up, I want to let all of you know that Amy is starting to accept new patients again. When we first launched her practice at the end of last year, she filled up really quickly and had about a 4 or 5 month wait list, I think, which she's now mostly worked through. So there are some spots starting to open up in her schedule, and I really recommend her for anybody who's looking for help with not just methylation, but any of the issues that we deal with in a functional medicine practice, chronic fatigue, gut problems, autoimmune conditions, mood disorders, skin issues, reproductive issues for both men and women, any kind of chronic illness which functional medicine is fantastic for, of course, especially when you approach it from an evolutionary perspective. And Amy, I have so much confidence in her, and in the year that we've worked together, I've just been so impressed with her capacity to absorb new information and put it into practice immediately. She's studied very closely with me over the past year, observed virtually all of my appointments. We've had lots and lots of training sessions. We talk almost on a daily basis. And she checks in with me regularly. If she has any questions about a patient's care, she'll come to me. And, I'm in contact with her, like I said, on a regular basis. So you get the same quality of care through Amy that you get when you come to see me. And it's exciting for me to be able to help more people with Amy on board and provide more support for my own patients for follow-ups with her on board. And I can't recommend her enough. So if you're interested, you can go to ccfmed.com. That's the California Center for Functional Medicine website. Click on the New Patients tab in the upper right, and then click on the section that pertains to working with Amy and I to learn a little bit more about how we both work with patients. And then you can there's a link there to a form where you can apply to become a new patient. So definitely do that if you're looking for some help. One advantage to working with Amy is she can work with patients all over the continental U.S., whereas I'm only accepting patients who live in California at this point. So you will have to come see Amy in person for the first appointment. That's just a requirement of the medical board, but you can do your follow-ups via phone or Skype. And because of the licensing situation here in California, she's able to accept patients from all over, whereas I'm a little bit more limited right now. So yeah, ccfmed.com. So Amy, thanks for coming on the show. It was great. We'll definitely do this again. Yeah, I hope you had a good time too.
Yeah, that was great, Chris. I think we covered a lot, and hopefully we kept it simple enough. But yeah, I think we could probably fit in a few more of these about methylation and still get into some more detail. There's a lot going on with methylation. It's exciting research to follow.
Absolutely. And this is just a teaser, but in the next few weeks, we're going to be launching a new series called From Chronic to Cured, which explores how we use functional and evolutionary medicine to treat chronic illness. And it's going to consist of podcast episodes, blog posts, and even free webinars. And I'll lead some of the episodes. Amy will lead some. Dr. Schwag, my co-director at the California Center for Functional Medicine, will be involved. And I'm really looking forward to it because we're going to be able to share a lot more about our process, how we approach diagnostics and treatment with a whole range of conditions that we'll feature in the series. We'll share case studies, and I think it's really going to help bring this to life for some of you. We've talked about a lot of these things over the years, but to be able to share some case studies from our clinic and really go a little bit deeper into how we're approaching this stuff is, I think, going to be really helpful for both patients and clinicians alike. So we'll make an announcement about that on the blog soon. And thanks as always for listening. I'm really grateful that you're a part of this community. And if you appreciate and enjoy the show, head over to iTunes and leave us a review. It really helps us out and brings new listeners to the show, and we can change more lives that way. So have a great couple of weeks, and I will talk to you then.